Today I decided I would make a Minecraft-like render engine in C++ and OpenGL 3.0. I wanted to test out my limits and see how good visual effects I could pull off on my own, so I thought this could be a good project to start off with. I used SFML for the window and user input, Glue for the OpenGL functions, and GLM, which is just the mathematics library for OpenGL. If you have no idea what I'm talking about, these are just the tools I used to make the game. First thing I did was I made a blank window and draw a square on it. The reason I did this was just to keep things simple at first. It's always better to break down the problem into multiple small steps instead of tackling it all at once, which is almost impossible in most cases. Next, I implemented a 3D camera. This is the part where I really used that GLM library. It really helped out with all the math that had to do with multiplying matrices, calculating vector dot products, and all this math magic. So yeah, that's pretty much it, and that's going to be the end of day one. Today I finished the cube and started drawing the chunks. I used an algorithm called Perlin noise to create the terrain. Perlin noise just lets you generate random terrain randomness, which isn't completely random like this type of noise. It's more of a smooth noise like this one. Then I tried texturing the cube. The problem with texturing the cube was that the way I was rendering it didn't really agree with the way I wanted to texture it. So if I wanted to fix this bug, I would have to redo the way I was rendering the cube all over again, and I had to do it a much dumber way. This time I got stuck with this annoying bug where the cube wouldn't texture properly, so I fixed this by drawing each side of the cube individually, and this makes all the sides completely independent of each other. And gives me more freedom with the way I would like to texture the cube. Then I tried multiple optimization techniques for drawing the chunks much faster and get higher FPS results. The technique that worked best by far was creating a huge mesh and adding each face to the mesh based on whether the face was visible to the user or not. The way I did this was simple. For every iteration of the 2D array of terrain heights, I would check the neighboring terrain heights and add a face to the left, right, front, or back based on whether the neighboring terrain height is lower than the current terrain height. And this way worked fine for the chunk. And that's pretty much the end of day 3. Today I played around with texturing, lighting, and backface culling. I made all the blocks redstone blocks so that the light effects is much more visible. Then I played around with the shaders and shader values and constants to get a value of light that I enjoyed. After that, I changed the way and order I was rendering each face so that I could enable backface culling. Backface culling just allows you to render one side of the cube so that you can decrease rendering times. If you don't know what I mean, this is really just a built-in OpenGL optimization that you can just turn on or off whenever, and it will pretty much double the performance of your program. So that's pretty much the end of day 4. Many things happened today. First of all, I played around with the camera constants and made it so that there was no longer this annoying bug where the user could literally flip the world upside down by moving the camera up or down too much. I also played around with the grass color so that it suits the world best and gives it a Minecraft feel. Then I created a cube renderer, and I did this because I wanted to create trees, and I also wanted to be able to batch them all into one mesh and draw all the trees all at once, just like I did with the world. I created another cube renderer specifically optimized for this type of task, and another cube shader, and everything worked well at the end. While coding everything, I was scared that the cube batching might not work or just render improperly because of the way I optimized the sprite batches based on the texture, but everything ended up alright thanks to the depth buffer, which I completely forgot about. Today I created a GUI class and made that cursor for my game. It was a simple cursor. I mean, it wasn't really a cursor, just an indicator for where the center of the screen was. I tried to make it look like the one Minecraft has, but completely forgot what it looked like. Anyways, whatever's. I started creating trees around the world. Then I created leaves and enabled transparency. For some reason, I got bored of the trees and started working more on the GUI class. I wanted to create a pause menu for the player to be able to change render settings in real time. It took a while, but I finally got something to draw to the screen and got a simple pause menu system to work. Today I created the slider class. The slider class really just allows the user to define his own number. So the value ranges from 0 to 1 in floating points. The hardest part about creating the slider was getting it to scale. In the checkbox class, I would just take the original percentage of the x, y, width, and height of the checkbox, and then just multiply that percentage by the new screen width and height after the screen got resized, and I got my new coordinates. Not with the slider though. I have to do at least 3 times more calculations to get the slider to properly scale with the window. But at the end, I got everything to work fine, so that's good, I guess. Then I created a matrix to move and pause, to move the pause menu into the screen smoothly, into and out of the screen smoothly. This took me some time to figure out, but I also came up with a function in my little silly maths class called isInRange. This function just checks whether a number is in range of another number at a specified range. The range is also passed in as a parameter. This function was especially useful because I wanted to not render the pause menu unless it's in the view of the user, just to improve FPS. And everything worked out nicely.